Hello and welcome to another episode of Maths with Mrs. Banks, where we make maths fun and easy to learn. And in this video, we're going to look at trigonometry for mathematics grade 11, paper 2. This comes from the November Eastern Cape 2022. And question 6 goes, 6.1, if negative 3 sine of beta minus 2 equals to 0 and beta is an element between 0 and 270 degrees, use a sketch in the correct quadrant to determine or calculate the value of 1 plus 10 squared beta without using a calculator. Now, whenever they tell you not to use a calculator, that means you'll be dealing with special angles, and those special angles will make it possible for you to calculate all of this without a calculator. All right, so let's go. 6.1 goes minus 3 sine beta minus 2 equals to 0. Negative 3 sine beta. Negative 3 sine beta minus 2. Minus 2 equals to 0. And we are told that this angle is between 0 and 270 degrees, which we're going to take a look at now. But let's clean this one up first. So that will be minus 3 sine of beta. Let's take this to the right hand side and it becomes 2. Now let's divide both sides by negative 3 to get sine of beta on its own. That will leave us with negative 2 over 3. Now let's try and figure out where this angle is situated in the Cartesian plane, the cast diagram. So according to the cast diagram, this is the situation that we have. All right, here is the cast diagram. Okay, to make it a bit thick. Cast. All right. Now, according to the cast diagram, this angle should, because we are told this angle should be between 0 and 270 degrees, meaning that it could either lie in the first quadrant, the second quadrant, or the third quadrant, because this is our 0 degrees. That is 90 degrees. This is 180 and 270 at the bottom, with 360 back to the origin. Now, meaning that this angle lies either here, first quadrant, or quadrant number 2, or quadrant number 3. Let's name the quadrant. Let's label them so you can see. It can lie anywhere between first, second, and third quadrant. Now, question is, where exactly does it lie? Now, it should be where your sine of beta is negative. Now, sine is positive in the first quadrant and the third quadrant. The only quadrant where, in these the restrictions we're given, the only quadrant it is negative at is the third quadrant. So, meaning that our angle should lie somewhere here. Let me get a different color. So, meaning that our beta will be looking like this. Okay, let's use a different color so you can see. So, meaning that this will be our beta, our angle beta. Now, let's take the color back. All right, there we go. Okay, now we know that our sine tells us your opposite over hypotenuse. So, meaning that therefore our hypotenuse is equals to 3. Remember, hypotenuse is always positive, never negative. And then our opposite is negative. Now, let's figure out all the other information that we need. We need to find what the adjacent is in this case. So, meaning this, okay, is what we have here. Okay, so meaning that the opposite is negative 2. We know that the hypotenuse is 3. We don't know what the adjacent is, and that's what we find. Now, using the theorem of Pythagoras, we can easily find what the missing information is, which is the adjacent. That's the reason. Always tell the reason why you can do that. Okay, this is a right angle triangle, so we can definitely use this. Now, we know that r is 3, so we substitute 3 all squared equals 2. That's what we're looking for. And we know that the opposite is negative 2. Take everything to the left hand side, so we make x the subject of the formula. Take out a calculator. Don't try to do this on your own in your head. We know you can calculate, but don't try this because we want you to maintain your level of accuracy when it comes to the answer that you get, because one inaccurate answer could mess up the whole question and you could end up getting the answer wrong in the end, and that gives us 5. So therefore 5 equals to x squared. Now that means x will be equals to plus or minus square root of 5. Why plus or minus square root of 5? Because like you can see in yourself, the y and the x could be anywhere, and in this particular case it's on the negative side because this is where the angle length and it is on the left hand side of the x-axis. So that makes therefore our x, the one that we will be dealing with, is -5. That's the one we will be dealing with. So now that we've got this information, we are armed with this information, we can now easily calculate the question that they asked us. Now we can find 1 plus 10 squared beta without any problem. Therefore 1 plus 10 squared beta will be equals to 1 plus 10 is opposite over adjacent, so it will be y over x all squared. Our y is -2. Our y is -2, and our x we just calculated now is negative square root of 5. So that will be -2 over, all right, let's remove this. It will be -2 over negative square root of 5, and this will all be squared, which is equals to, take out your calculator, don't try and do this by hand, you don't need to anymore. Okay, so that will be 1 plus, open bracket, common fraction button, -2, downward arrow, negative square root of 5, right arrow, close bracket, x to the power of 2, and that gives us an answer of 9 over 5. So this is equals to 9 over 5, and that's your answer. Next question, 6.2 goes, 6.2. 6.2 goes, if cos of 75 degrees equals to m, express each of the following in terms of m, showing all your working. Now this type of questions can get a bit tricky, but this is the tip that you need to know. Once you figure out how all of them are connected to your cos, it makes it very easy. Now you use all the information you can use, and that includes the square identity, and I'm going to show you exactly what we are talking about. This is m. All right, now they said 6.2.1, they want us to calculate cos square of 105 degrees, cos square of 105 degrees, cos squared of 105 degrees. Okay, you know obviously that means it equals to the cos of 105 degrees all squared. That's what it means. Okay, now how does cos of 105 degrees relate to cos of 75 degrees? Okay, so obviously that is equals to the cos of 90 degrees plus 15 degrees. All right. And that lands us in the second quadrant, and in the second quadrant that becomes the co-function. So that will be, okay, in the second quadrant, this is where we land. Okay, it lands us in the second quadrant. Now that becomes the co-function of cos is sine, but because cos is negative in the second quadrant, that sine will also be negative. So that will be negative sine of 15 degrees all squared. And sine of 15 degrees can also be written as, all right, so which is equals to, obviously it will be squared, so that is equals to minus in the sine of, Okay, minus sine of, okay, that will be 90 degrees minus 75. 15 is 90 minus 50, minus 75. 90 minus 15 degrees, the acute angle we're dealing with is 75, which is what we are dealing with in this one. So that will be 90 degrees minus 75. It can be written as 90 degrees minus 75. All right, which is obviously cos of, so that is equals to minus, okay, cos of 75 degrees. That's what it is, all squared. And that gives us cos of 75 degrees is what? That is m. So that is, okay, negative m all squared, which is equals to m squared. 6.2.2. Sine of 15 degrees. We already dealt with that. Sine of 15 degrees should be easy to deal with. Sine of 15 degrees. That is equals to sine of 90 degrees minus 75 degrees. This one lands us in the first quadrant. There is 90 minus 75 degrees, and we change that to the cofunction because of the anchor angle, which is 90 degrees. So that changes into positive cos of 75 degrees, which is equals to simply m. And that's how you deal with this type of questions. Next question. 10 of 15 degrees, 6.2.3. 10 of 15 degrees, 6.2.3. 6.2.3. That is the 10 of 15 degrees. We know that 10 is, that can be expressed as sine over cos, and that's exactly how we express it. That is equals to sine of 15 degrees over cos of 15 degrees. We've already calculated this too. Okay, let's go back and we will see exactly what this gives us. Cos of 15 degrees. All right, cos of sine of 15 degrees is simply m. All right, okay. Sine of 15 degrees is equals to m. Now the cos of 15 degrees will be, okay, let's use this. Now cos of 15 degrees, remember the square identity I told you about, cos of, okay, sine square of theta plus cos square of theta equals to 1. That is the square identity, and as such then you can express any of the, in terms of, in fact let's do this on the left hand side, we can express any of the ratios, trigonometric ratios, in terms of the other using this square identity. So that can be expressed as 1 minus sine squared theta, which therefore cos of theta can also be expressed as the square root of 1 minus sine squared theta. All right. So meaning that, okay, cos of 15 can be expressed as the square root of 1 minus sine theta. All right, so that is equals to sine of 15 degrees, sine of 15 degrees over 1 square root of 1 minus sine squared 15 degrees. All right. Sine of 15 degrees equals to m. We already calculated that. That is equals to m over 1 minus square root of 1 minus m squared. Square root of 1 minus m squared. And that's how you solve this type of questions. Okay. 1 minus m squared. All right, next question. Next question, 6.3. Given the expression, there's the expression, simplify the expression, that should be easy. So we've got cos of 180 minus k 6.3.1. Okay, let's remove this. 6.3.1 cos of 180 minus k. 6.3. And then we've got 6.3.1. We're supposed to simplify cos of 180 degrees minus k. We're going to use the cos diagram a lot in these questions. So you need the cos diagram. Times sine of k minus 90 degrees minus 1. Times sine of k. Sine of k minus 90 degrees minus 1 all over. And this is all over 10 squared 540 plus k times sine 90 degrees plus k. 10 540 plus 10 squared 540. 540 degrees plus k. Times sine of 90 plus k cos of negative k. Sine of 90 plus k times cos of negative theta negative k. All right, let's just double check the question so that we can. Okay, yes, it is squared. All right, now let's reduce. All right, according to the cos diagram, here is the cos diagram. Let's draw the cos diagram on there so we can work this one out. Cos of 180 minus k. 180 minus k lands us in the second quadrant, and cos is negative there, so that will be negative cos of k. Negative cos of k times sine of 180. Sine of k minus 90 can also be written as minus, okay, sine of minus in bracket 90 degrees minus k. 90 degrees minus k, so we can see exactly what it is that we're working with. All right, and then minus 1. We're going to work this one out. I just want to do this stage by stage so you see exactly where everything comes from. 540 plus k. 540 plus k, that is over 360 degrees. So you go 540 minus 360, so you can see exactly. And that gives us 180. So that will be 360 degrees plus 180. So that will be 10 squared. 360 degrees plus 180 degrees plus k, obviously. All right, that is sine of 90 degrees plus k. Sine of 90 degrees plus k. 90 plus k lands us in the second quadrant, and sine is positive there, so the originator and the cofunction, which is going to be cos, will also be positive because of the original trigonometric ratio. All right, so that is being positive in the second quadrant. That will be cos of k. Now, cos of negative k minus k lands us in the third quadrant because that can be from there, and you go minus k. That lands you in the fourth quadrant, and cos is positive there, so it will be positive. That will be cos of k. Negative cos of k. Sine of negative 90 degrees minus sine of the negative sign of anything is negative, so that will be negative cos of k times negative sine of 90 degrees minus k minus 1 over, okay, 10 of 360 plus 180. 360 plus 180 lands us at that, so the 360 just rearranges everything, takes everything back to 0, so that will be 10 squared of 180 degrees plus k. All right, times cos k times cos k. That'll be cos squared k. And let's just double check the question. Yes, everything is matching with the original question. Now let's simplify this one and let's reduce this. So that will be negative k cos k minus cos of k times, okay, sine of 90 degrees minus k. Sine of 90 degrees minus k lands us in the first quadrant, and the cofunction of sine there is cos. It's also positive because everybody is positive in the first, so that will be negative cos of k minus 1 all over 180 plus k. 180 plus k lands us in the third quadrant, and 10 is positive there, so that will be 10 of k. So that will be 10 squared k. 10 squared of k times cos squared k times cos squared k. Negative times negative, they cancel out. Okay, let's use different color. The negatives cancel out, and that leaves us with cos squared k minus 1. So that is equal to cos squared k minus 1 over and that is 10 squared k times cos squared k. 10 squared k times cos squared k. We know that this is equals to cos squared k minus 1. Remember, sine squared k. Remember, cos squared k, sine squared k, according to the square identity. Sine squared of theta can be written as 1 minus cos squared of theta. So meaning that minus that will give us, minus all of that will give us cos squared theta plus minus 1. And that's how that translates. So that is equals to negative sine squared k over 10 squared k. That is sine squared k over cos squared k. Now multiply that by cos squared k. The cos squared cancel out, and that leaves us with minus sine squared k over sine squared k, and that gives us negative 1, and that is equals to negative 1 because these two cancel out. These two cancel out, and that leaves you with negative 1 is the answer there. So next question, to remove this, 6.3.2. 6.3.2 goes, determine or calculate the value of k is an element of 0 to 360 for which the expression is undefined. When is this undefined? It's undefined when the ones at the bottom give you 0. If any of the ratios at the bottom is equal to 0, then this will be undefined. So that will be 10 squared the expression is undefined. It's undefined when the numbers at the bottom. When 10 squared (540 degrees plus k) equals to 0, or sine of 90 degrees plus k equals to 0, or cos of negative k equals to 0, or when cos of negative k equals to 0. That gives us okay, 10 squared 540 plus k equals to 0 when 10 therefore 10 of 540 plus k equals to 0, meaning that 10 of k equals to 0, because that's what we get to when we reduce this, meaning that therefore k equals to 10 to the minus 1 of 0, which gives us the angle between 0 and 360. So shift 10, 0 equals to 0. Okay, for this one, it's when k equals to 0 degrees. Let's calculate for the other ones. All right, for sine of 90 degrees plus k, sine of 90 degrees plus k, this gives us, this will be equals to 0 when therefore 90 degrees plus k equals to sine to the minus 1 of 0, which gives us shift sine 0, that gives us 0 degrees, meaning that k will be equals to negative 90 degrees, and that is not what we are looking for. And then for the last one, cos of minus k, alternatively this can be therefore cos of k equals to 0, meaning that therefore k equals to cos to the minus 1 of 0, which is equals to shift cos k cos of 0 equals to 90 degrees. And the last one, cos of minus k equals to 0. Therefore, negative k, which is cos of k, because that's what happens when you reduce this, meaning that k equals to cos to the minus 1 of 0, which is equals to 90 degrees. Therefore, the expression is undefined when Therefore, the expression is undefined when k equals to 0 and when k equals to 90 degrees. When k equals to 0 or k equals to 90 degrees. Next question. Prove that 1 plus sine theta minus 1 over sine theta minus 1 minus sine theta over 1 plus sine theta equals to 4 tan theta over cos of theta. Alright, 1 plus sine theta over 1 minus sine theta. Okay, so we need to prove the left hand side, 6.4. Left hand side equals to 1 plus sine theta over 1 minus sine theta. Let's go back to the question. We need to prove that it is close to the right hand side. Minus 1 minus sine theta over 1 plus sine theta. All right. Minus 1 minus sine theta over 1 plus sine theta. We need to prove that it is close to the right hand side. Okay, let's work on the left hand side. We've got a lowest common denominator, the LCD equals to 1 minus sine theta times 1 plus sine theta. Let's use that. 1 minus sine theta times 1 plus sine theta. That is our LCD. Now let's multiply. Okay, so let's rearrange this fraction. So the LCD now becomes the numerator, the denominator. Alright, so we've got 1 minus sine theta times 1 plus sine theta. This is our denominator. Now to find what's in the numerator, we must multiply each of the fractions by the lowest common denominator. So we multiply this by 1 minus sine theta times 1 plus sine theta. Okay, 1 minus sine theta is cancelled out, and you're left with 1 plus sine theta times 1 plus sine theta. Alright, so that will be 1 plus sine theta times 1 plus sine theta. Minus, okay, let's extend this, minus alright, now we multiply this fraction by the LCD. So okay, 1 minus sine theta over 1 plus sine theta multiplied by 1 minus sine theta times 1 plus sine theta. Well, the 1 plus sine theta is cancelled, and you're left with 1 minus sine theta times 1 minus sine theta. 1 minus sine theta times 1 minus sine theta. Now this is, let's multiply the top. So using FOIL, 1 plus 1 times 1, it's 1. So that will be 1 plus 2 sine theta plus sine squared theta plus sine squared theta minus, this one will be 1 minus 2 sine theta plus sine squared theta. 1 minus 2 sine theta plus sine squared theta all over. This is a difference of two squares, so it gives us 1 minus sine squared theta. Now let's simplify the numerator. So that will be, okay, let's take out the brackets. Remove the brackets. Minus 1 plus 2 sine theta minus sine squared theta all over 1 minus sine squared theta. 1 minus sine squared theta, and that is equals to, let's see, 1 minus 1, the ones cancel out. Okay, let's eliminate that. They add up to 0, and the sine squared thetas also add up to 0. So we're left with 4 sine theta, 2 sine theta plus 2 sine theta. Okay, so that will be 2 sine theta plus 2 sine theta. I wanted to see exactly what we're left with, over 1 minus sine squared theta, which is equals to 4 sine theta over 1 minus sine squared theta is also cos squared theta, which is equals to 4 sine theta over 1 cos makes, okay, over cos times cos theta times cos theta. Sine theta over cos theta, that is 10 theta. So that will leave us with, therefore, that will be equals to 410 theta over cos theta. 410 theta over cos theta, which is definitely equals to the right hand side. And that matches. We've proven that. Next question. Determine the general solution of 6 sine squared theta plus cos theta equals to 4. Whenever you have a situation like this, try to get every one of these trigonometric ratios in the same ratio, either sine or cos, make them the same. So 6 sine squared theta plus cos theta, that is 6.5. 6 sine squared theta plus cos theta, that is equals to, let's see what they say it's equal to. That is equals to 4. That is equal to 4, meaning that therefore, okay, now so sine squared theta can be written as 1 minus cos squared theta, and that matches with the cos theta. So let's convert that to that. So that will be 1 minus cos squared theta plus cos theta equals to 4. Now you have what looks like a quadratic equation, which is exactly what we were aiming for. So that is 6 minus 6 cos squared theta plus cos theta equals to 4. Let's take everything to the left hand side. All right, so that gives us minus 6 cos squared theta plus cos theta plus 6 minus 4, which is equals to 0. Now that leaves us with negative 6 cos squared theta plus cos theta plus 2 equals to 0. Now divide all throughout by negative so that we can have the square by positive. That is minus cos of theta minus 2. And now we can factorize. That is the same as, okay, let me show you. That is the same as if you let cos equals to y. Cos of theta equals to y. Therefore, that will be 6y squared minus y minus 2 equals to 0. Now, if this makes it easier for you to factorize, use this. So let's use this. That becomes, all right, here are the factors of 6 that we can use to factorize. 6 times 1, 3 times 2, and then the factors of 2 are just 2 and 1. Now, the combination that can give us 1 is, I believe, this combination to give you good 3 times 1 and 2 times 2. So we're going to go 3y times 2y. Now, where do we put the 2? Where do we put the 1? Easy peasy. Okay, we can put 3 times 1 and 2 times 2. All right, good. All right, now our middle term is negative, so meaning that we must have the bigger combination of factors be negative. So this should be negative and that should be positive, and that's how you factorize this. Now let's check. 6y squared plus 3 minus 4. 3 minus 4, that is negative 1. Y minus 2, and that is good. Now let's get back to our colors so that you can see what's happening. All right, so now let's go. Therefore, all right, 3y minus 2 equals to 0, or 2y plus 1 equals to 0. Remember, these are not our ultimate variables. Our variables are cos theta. So that is 2y equals to negative 1. Therefore, y equals to 2 over 3, or y equals to, divide both sides, negative 1 over 2. This is not what we're dealing with. We're dealing with cos, so we refer or transfer back to cos. Therefore, cos of theta equals to 2 over 3, or cos of theta equals to minus 1 over t. Therefore, cos of theta equals to cos of theta equals to 3 over 2, or cos of theta equals to negative half. Okay, let's just go back and double check that. Yes, that is 2 over 3, not 3 over 2. Sorry about that. 2 over 3. Okay, let's fix that. 2 over 3. All right, now let's work on each one of this. All right, therefore, let's start with the cos of 3. For cos of 2 over 3, theta equals to 2 over 3. Okay, let's go back to the question to verify. Is this a general solution? It's a general solution, no problem. Okay, now let's go back. Let's start with, okay, here is the reference angle. Step number 1, the reference angle. So we go the reference angle. To find the reference angle, you go theta equals to cos to the minus 1 of 2 over 3. Take out your calculator and it will give us what the reference angle is. So you go shift cos, common fraction button, 2, downward arrow 3, right arrow, close bracket equals 2, and that will give you 48,189,685. 48,189,6,851 degrees. Okay, we can like simplify that, which, okay, if you round off correct to 1 decimal, that will be approximately 48,2 degrees. All right. This is your reference. This is our reference angle. And now, for where cos of theta is positive, using the cos diagram. Let's use the cos diagram. Now, cos is positive in the first and fourth quadrant. Let's number them so you can see. Cos is positive. Cos is positive in quadrant 1 and 4. And 4. All right. In quadrant 1, theta equals to simply the reference angle, because it's in the first quadrant. The reference angle plus 360 plus k times 360, where k is an element of integers. All right, now, meaning that therefore our angle is, the reference angle is 48 degrees point 2, 48,2 degrees plus k times 360 degrees. Where k is an element of integers, we're not going to waste time with that. Now, that's in quadrant 1. Now, in quadrant 4, this is how we express the angle. It's 360 degrees minus the reference angle. So, theta will be equals to 360 degrees minus the reference angle plus k times 360 degrees, because the period of cos is 360 degrees, where k is an element of integers. Therefore, theta equals to 360 degrees minus 48 degrees, 2 plus k times 360 degrees. All right, now 360 minus 48, 2, 360 minus 48, 2, that is equals to 311,8. Therefore, theta equals to 311,8 degrees plus k times 360 degrees, where k is an element of integers. Now, that's for the first, cos of theta equals to 202 over 3. Now, for the second one, okay, for cos of theta equals to minus half, cos of theta equals to minus 1 over 2. All right, here is the reference angle. The reference angle, to find the reference angle, you go theta equals to cos of to the minus 1 of positive 1 over 2. Always deal with the positive to find. So let's go shift cos of, common fraction button 1, downward arrow to right arrow, close bracket equals to, and that gives us 60 degrees. The reference angle is 60 degrees. So now let's use, now cos is negative according to the cos diagram. Cos is negative in the second and third quadrant. Cos is negative in the second and third quadrant, in quadrant 2 and 3. Therefore, in quadrant 3, in quadrant 2, let's start with quadrant 2. In quadrant 2, how do we, it's going to be 180 minus the reference angle. Theta equals to 180 degrees minus the reference angle plus k times 360 degrees, where k is an element of integers. We're dealing with the general, which then gives us, therefore, theta equals to 180 degrees minus 48 degrees, 2, plus k times 360 degrees. Alright, so that's 180 minus 48.2, 180 minus 48, 2, and that gives us 180 minus 48, 2. Is it 48, 2 or 42,8? Yeah, it's 48, 2. Yes, so that gives us what? It gives us 131,8. 131,8. Therefore, theta equals to plus k times 360 degrees, where k is an element of integers. All right, now in quadrant number 3, the angle is there. It's 180 plus the reference angle. In quadrant 3, theta equals to 180 plus the reference angle plus k times 360 degrees, where k is an element of integers. Now we go, therefore, theta equals to 180 degrees plus 48, 2 plus k times 360 degrees. Now 180 plus 48, 2, 180 plus 48, 2, that is equals to 228, 2. Therefore, theta equals to 228, 2 degrees plus k times 360 degrees, where k is an element of integers, obviously. Okay. Now, therefore, the general solution is, now we combine all of these. Okay, let's start with the smallest. Okay, so the first one was 48, 2. All right. And the second one is 131,8. The third one is 228, 2, and the last one is, therefore, the general solution is theta equals to 48, 2 degrees plus k times 360, or theta equals to 131,8, or theta equals to 131,8 plus k times 360 degrees, or theta equals to the next one, so it's 48, 2, and then the next 228, 2 plus k times 360 degrees, or theta equals to the last one is 311,8, or theta equals to 311,8 degrees plus k times 360, where k is an element of integers, where k is an element of integers, and that's your general solution. Next and last question is, if P equals to 10A plus sine A and Q equals to 10A minus sine A, prove that P times Q equals to 10 squared A times sine squared A. We're going to do this right here, so you can see exactly how the whole question evolves into what needs to be done. So 6.6. All right, so we've got PQ will be equals to 10A plus sine A times 10A minus sine A, and this is a difference of 2 squares, so that leaves us with 10 squared A minus sine squared A. So that leaves us with 10 squared A minus sine squared A. 10 can be written as sine over cos, so that leaves us with sine squared A over cos squared A minus sine squared A. Which leaves us with a lowest common denominator of cos squared A. That leaves us cos squared A. And that leaves us with sine squared A if we multiply both sides. Minus sine squared A times cos squared A. Now you take out a common factor. The common factor is sine squared A. Let's take out a common factor. That leaves us with 1 minus cos squared A. 1 minus cos squared A over cos squared A. We know the 1 minus cos squared A, that is. That is sine squared A. So that is equals to sine squared A times sine squared A over cos squared A. And we know that sine squared A over cos squared A, that gives us 10 squared A. And that will be 10 squared A times sine squared A. And that is equals to the right hand side. And there, we've proven it. And that is the end of the question and the video. Thank you so much for watching. See you in the next one. Bye-bye.